Hello again, I have question 30. It says, study the opposite circuit and answer the following question. They want I3. Okay, we come here to the circuit, they want I3 right here. We notice that I3 is in the right loop. Okay, but unfortunately I don't have I2, I don't have R1, so I need to depend on the left loop also to find I3. Okay, so let's start with the left loop. Okay, in the left loop I will go, let me write here, left loop. Okay, I will go anti-clockwise or counterclockwise. Okay, so we start with the battery. Since it's going anti-clockwise, okay, the direction, my direction will go out of the positive of the battery, so it's going to be 8.6. okay, now I have the current I1, it goes through the resistor 7, and since the I1 agrees with the direction of motion, is going to be minus I1 multiple R, which is minus 1.8 multiple 7. Okay, now I come back to the resistor R1, okay, which I have the current I2 that goes through it. Okay, the I2 will complete into the R, right? So you can see that I2 doesn't agree with the direction of motion, so it's going to be plus I2 multiple R1, and I don't have any of them, so I'll put I2 R1 equals to 0. I fix this equation. I will have 4 minus I2 R1, okay, which equals to 0, and this will give me that I2 R1 equals to 4. Okay, I am going to use this now when I apply Kirchhoff's second law on the right loop. Okay, guys? Okay, I will divide here. Okay, so now let's apply Kirchhoff's second law on the right loop. On the right loop, I will go also anti-clockwise. I will go anti-clockwise like this. Okay, so this is the right loop. Okay, anti-clockwise or counterclockwise. Okay, so I start with the batteries. I have here the 24, and the direction, the green one, anti-clockwise, it goes out of the positive of this battery, so it's going to be positive 24. Let me erase these things in here. Okay, now for the V1, this battery, okay, the direction of motion, it goes out of the negative, so it's going to be minus 8.6. okay, now I2, as we agreed, it goes through the resistor R1, right? And since it agrees with the direction of motion, it's going to be minus I2 R1. Okay, now I have the resistor R2 that has the current I3 goes through. It is going to be, and of course I3 agrees with the direction of motion, so it's going to be minus I3 R2, which is going to be 3 I3 equals to 0. Okay, notice here I have I2 R1. Okay, I use this value here. Okay, the multiple of them is 4. So I just substitute, is going to be 24 minus 8.6 minus 4, and I take the I3, I take it to the other side, it becomes positive. Okay, so I will have 3i3. Okay, let me use my calculator. I will have 24 minus 8.6 minus 4 equals to 11.4. So the 3i3 is going to be 11.4. Now if I want i3, I just divide both sides on 3. Okay, divide 3. I will get 3.8 ampere. Okay, 3.8 ampere. Okay, so this is the value of I3. Notice it's positive, so no need to change the direction. Now in part B, they want the value of R1. Okay, guys, they want R1. So in order to find R1, I only need to find I2, right? Because you see this equation here, I found that I2 R1 equals to 4. So let's apply Kirchhoff's first law on the upper junction. I will use okay, blue. On this junction right here, I will have the sum of currents entering equal the sum of currents leaving. So which one is entering? It's I3. Which ones are leaving? I have I1 and I2. Okay, I have I3, I have I1, so I can find I2 equals I3 minus I1, which equals 3.8 minus 1.8, which equals 2 ampere. Okay, so this is the value of I2. Now I use this equation that I told you about here. Okay, the I2 R1 equals to 4. This means that R1 equals 4 over I2, which is 4 over 2, which gives me that R1 equals 2 ohm. Okay, I hope it's clear. Let me check if I have a C. No, there's no C. So this is A and B of this problem. I hope it's clear. If you have any question or comment, please leave it under the video. Have a great day. Bye bye.